Welcome and greetings to all from the OMNIX USA team. We are grateful you could join us today for the latest installment of the OMNIX educational series, designed to empower our customers when making tooling decisions. Today's webinar will provide a comparison between aesthetic or cosmetic bending applications versus high volume bending applications. The presentation will take 15 to 20 minutes, followed by a live question and answer conference call. We encourage you to submit your questions at any time during the presentation using the chat function on the screen. Today's agenda will compare cosmetic and high volume bending, including the production environments and end-use applications, bender features, materials used, quality requirements, and tooling features. The presentation will be followed by the live question and answer session. The production environment varies considerably between aesthetic or cosmetic bending applications versus high volume applications. Aesthetic or cosmetic bending typically entails a relatively low production volume, maintaining maximum shape control and the highest possible quality on the bent tube forms. Cycle time is generally not a concern for aesthetic or cosmetic applications, and these applications typically incorporate manual loading and unloading of tubes. For the purposes of this presentation, we will use the term cosmetic to refer to both aesthetic or cosmetic applications. High volume bending, on the other hand, inherently entails high production volumes. It allows for intermediate levels of shape control, medium to high quality levels, and consistent repeatable results. The goal of high volume production is to achieve sufficiently high quality while minimizing production cycle times. High volume tube bending also typically uses robots to load and unload the tubes. Some common examples of cosmetic bending applications include aerospace fluid conveyance, furniture, handrails, invisible grips, aftermarket performance exhausts for automobiles and trucks, and internal components for heating, ventilation, and air conditioning systems. Some common examples of high volume bending applications include OEM exhaust systems for automobiles, trucks, and off-highway vehicles, frames, racks, and roll cages for all-terrain vehicles, as well as other components for heating, ventilation, air conditioning, and refrigeration. Another difference between cosmetic bending applications versus high volume applications is the type of tube bending machine and the machine features that are commonly used. Cosmetic bending can use hydraulic, hybrid, or all-electric benders with single or dual heads, and cosmetic bending typically uses single-stack machines. High-volume bending can also use hydraulic, hybrid, or all-electric benders, while single-head benders are the most common. High-volume bending almost always uses a multi-stack configuration, where dies for multiple bend radii are stacked together to reduce cycle time and optimize production efficiencies. Cosmetic tube bending applications ideally use the highest quality tube material that is available. All types of tube materials can be used for cosmetic bending, including copper, aluminum, steel, stainless steel, nickel alloy, and titanium. The durable tooling for cosmetic bending is typically made from nitride of 4140 material. Nitride of 4140 is more forgiving than tool steel and tends to mushroom and not to crack if crashed. The case-hardened shell is harder than tool steel at the surface level, and if you wear through the case hardening, it can be case hardened again. High volume bending applications do not necessarily use the highest quality tube material that is available. On the other hand, high volume bending aims to achieve repeatability across multiple production runs over a medium to long-term horizon, so maintaining consistency of the tube material is paramount. The most common types of tube materials for high volume bending are steel, stainless steel, and aluminized tubes. The durable tooling for high volume bending is typically made from through hardened tool steel. Cosmetic and high volume tube bending applications have markedly different quality requirements. Cosmetic bending requires smooth bends with no wrinkles or markings on the bent tubes. Cosmetic bending has stringent out-of-round deformation requirements. The goal of cosmetic bending is to achieve maximum bend quality and shape control of the bent tube forms. For high volume bending, some wrinkling may be okay and markings are common. Any out-of-round quality requirements are typically defined in the part specifications. The goal of high volume bending is to achieve minimum acceptable quality standards, while the key is repeatability across multiple production runs over the long term. To achieve the stringent quality requirements required for cosmetic bending, certain tooling features are commonly specified. Mandrel clearances are typically held very tight for cosmetic bending. When wiper dies are required, square back wiper dies are most commonly used. The typical durable tooling material for cosmetic bending is 4140 nitrided, and Delrin can be used for bending softer materials. Interlock and captive lip are optional tooling features that are often specified for cosmetic bending. Lastly, smooth grips or gripless grips are recommended for cosmetic bending. Mandrel clearance refers to the clearance between the ID of the tube and the mandrel components. For cosmetic bending applications, mandrel clearances should be held tightly to maximize the shape control of the bent tubes. For standard pitch mandrels, the finished shank diameters are held to 6/1000 of an inch from the tube ID, while the ball diameters are held to 11/1000 of an inch from the ID of the tube. For closed pitch or thin wall mandrels, the finished shank diameters are held to the same 6/1000 of an inch from the tube ID, while the ball diameters are held to 9/1000 of an inch from the ID of the tube. The difference between the shank clearance and the ball clearance can be referred to as the shank to ball step down. Too much mandrel clearance can result in flattening along the outside radius and wrinkling along the inside radius of the bent tube. Too little mandrel clearance can create additional drag that can squeeze the lubrication out of the tube and cause the grips to slip. In extreme cases, too little clearance can result in a mandrel being too large to fit inside the ID of the tube. Square back wiper dies are typically specified for aerospace bending and other highly cosmetic applications. Square back wiper dies are machined from a solid block of material and provide maximum support of the tube along the inside radius. Depending on the wiper length and other factors, square back wiper dies can usually be recut or refurbished after the tip becomes worn. (4140) nitrided material is OMNI's standard durable tooling material, and it is recommended for cosmetic bending. When crashing occurs, 4140 nitrided tends to mushroom rather than cracking. 4140 nitrided has a case-hardened shell that is harder than tool steel at the surface level. And if you wear through the nitride layer, 4140 nitrided tooling can be case-hardened again in most cases. Aluminum bronze pressure dies may also be used to reduce markings when bending stainless steel, nickel alloy, or titanium tubes. Delrin can be specified for bending even softer tube materials such as aluminum or copper. Delrin can eliminate markings on the bent tubes, but it will wear much quicker compared with metal tooling. Next, we will highlight an optional tooling feature called interlock or reverse interlock. Reverse interlock gives the bend die a recessed channel for the clamp die and pressure die to lock with vertically. Interlock improves the tooling alignment during the bending process and eliminates markings caused when the tooling is misaligned. One limitation for interlock dies is that there must be at least 1/4 inch of material above and below the channel. Next, we will highlight an optional feature called lip or captive lip. Lip is a feature that is added to bend dies and wiper dies for cosmetic applications. Lip is an extension of the bend die tube groove that extends past the tube center line and contains the tube material from flowing between the tools. This reduces markings along the top and bottom of the bent tubes. For lipped tooling, the pressure die must be cut back by the same amount in order to prevent collisions with the bend die. One limitation of lip tooling is that you cannot use it in combination with non-lipped tooling. The last tooling feature we will highlight are the grips. For cosmetic bending applications, smooth or grip blast grips are specified to prevent markings on the bent tubes. Smooth grip has no surface treatment. Smooth grips can minimize markings on the bent tubes, but require longer grip lengths. Grip blast grip is a gentle roughening of the functional surface of the clamp. Grip blast provides comparatively more grip than smooth clamps and does not lower the quality of the outer surface of the tubes after gripping. We will now move on to the tooling features for high volume bending. Mandrel clearances are typically loose fit and dialed in by application for high volume bending. Inserted nose mandrels may be used to achieve long-term cost savings. When wiper dies are required, close approach wiper die holders with replaceable wiper inserts are commonly used. The typical durable tooling material for high volume bending is through hardened tool steel. Interlock may be specified for high volume bending. And lastly, serrated or knurled grips are recommended for most high volume applications. As mentioned earlier, mandrel clearance refers to the clearance between the ID of the tube and the mandrel components. For high volume bending applications, mandrel clearances are held within a specified range to maximize uptime and achieve a consistent, repeatable level of quality. For standard pitch mandrels, the finished shank diameters are held to 6/1000ths of an inch from the tube ID, while the ball diameters are held to 11/1000ths of an inch from the ID of the tube. For close pitch or thin wall mandrels, the finished shank diameters are held to the same 6/1000ths of an inch from the tube ID, while the ball diameters are held to 9/1000ths of an inch from the ID of the tube. Too much clearance can result in flattening along the outside radius and wrinkling along the inside radius of the bent tube. Too little mandrel clearance can create drag that can squeeze the lubrication out of the tube and cause the grips to slip. Sometimes the mandrel may be too large to fit inside the ID of the tube. Close approach wiper die holders with replaceable wiper inserts are specified for most high volume applications. Close approach wiper holders are used for minimizing tube waste, achieving a shorter working length by extending the mounting out behind the wiper, and allowing the collet to get closer to the bend die, which shortens the required tube length. Through hardened tool steel is recommended for durable tooling for high volume bending. Through hardened tool steel will result in longer tooling life for high volume applications compared with 4140 nitrided material, provided that the dies are not crashed or dropped. Through hardened tool steel maintains its hardness throughout the cross section of the die rather than only being harder at the surface. Interlock or reverse interlock can be specified for high volume bending applications. As previously mentioned, reverse interlock gives the bend die a recessed channel for the clamp die and pressure die to lock with vertically. This improves the tooling alignment during the bending process and eliminates markings caused when the tooling is misaligned. For high volume bending applications, serrated or knurled grips are specified to minimize the clamping length required to grip the tubes. Serrated grip has a machined serrated surface. The coarseness of the serration is chosen based on the diameter of the tube. Coarseness is specified by the number of teeth per inch. Knurled grip is a machined coarse surface treatment. Knurled grips provide similar performance as serrated grips and result in a different wear pattern on the bent tubes. Similar to serrations, the level of coarseness for knurls is chosen based on the diameter of the tube. We will now move on to the live question and answer session. Any unanswered questions submitted during the presentation will be covered during the question and answer call. To join the conference call, please dial 970-822-8670 and use the conference ID provided in the chat box. On behalf of the entire OMNIX team, thank you for joining us today.